covalent bond is a chemical bond formed by sharing a pair of electrons. This is the key word right here. Sharing. So imagine you have hydrogen right here. And there's another hydrogen. We have the s orbital. Look at it as a sphere. There's an electron in each. When they come together, notice how they form a bond between them right here, where this area becomes now, or this probability density becomes even more dense. And that's basically your bonding, your covalent bond. Well, let's look at it from another perspective. So again, where does that come from? Let's say if we have just a dot. Well, hydrogen wants to be like helium. Helium has 2 valence electrons. Imagine you have 2 hydrogen atoms. Before, you saw an ionic bonding, losing and gaining, right here. It was very nice and simple. Well, this can't happen anymore. The reason why is because they're both hydrogen atoms. One can't gain and the other one lose. If one gains, it's going to be happy, but the other one is unhappy. Whereas in the last one, you killed 2 birds with 1 stone by making one lose to become like the noble gas and one gain to become like the noble gas. Can't happen here. So what happens is that what chemists think has happened, and of course this is the foundation of what we're doing here, is that these atoms come together like we're saying here, and they say, okay, we can behave. And let me just make this a little bit bigger because we're going to need space. Let's come together. You pitch in your electron. I pitch in my electron. We're going to make both electrons happy because now they can share 2 nuclei. And this makes this atom have 2, and that atom have 2. So if you look at it, this one has 2, and that one has 2. But the total is 2. So this one has 2 valence, this one has 2 valence, but the total is still 2, which can be sometimes mind-boggling. Well, what I want you to think of it is that the idea is that those electrons double count. Okay. Well, okay. So what do you mean by that? So this one has 2 electrons, okay, and that one has 2, but it's all 2. Well, you can think of it this way. Is if we have a parent, let's say I have a mother, we have parent 1, and you have parent 2, let's say, the father. So they're together, the mother, father, and they have children, right? But when the mother is asked, how many children do you have? She says, 2 children. When the father is asked, well, how many children do you have? He says, 2 children. Does that mean that they have 4 children? No, the total is still 2 children. Because they're sharing, right? Because those kids are shared between the father and the mother. Ask the father how many children I have. I have 2. Ask the mother how many children I have. I have 2. But the total is 2. So please think of it this way, that those electrons, those lone pairs double count. They double count. Well, let's look at another example. We have an H and we have a Cl. H has one valence electron. Cl has 7. Is there a way for H to be happy and Cl at the same time? What do you think? Is there a way you can apply this covalent bond? Yes. So what we could do is we could these share them. So that would make it like this. Okay. And now look, H is happy because it has 2 valence, and Cl is happy because it has 8. Count them. That's 8 for Cl, and H is happy. Very well. We need to start with some terminology here because that's important. Well, let's start. The pair of electrons that was used to give Cl the octet and H the duet, you see it between them. This is what we call a bonding pair of electrons, shared pair, or of course, most important is that that's a covalent bond. And look at the name covalent. Co means sharing, right? Valent means what's the valence electrons. So they're sharing the valence electrons. Okay, very well. What about the other ones? Well, the ones that are not shared, what do you think they're called? All of these. Let me fix this one, the last one. Those are called non-bonding pairs, unshared pairs. I don't want to belabor this, unshared. Or most importantly, we call them, and I want you to use this, lone pairs of electrons. Lone pairs. So of course, you still have to know what non-bonding means. I mean, the word is going to give it out, okay? Non-bonding means they're not involved in a bond. So they belong to one atom. So lone pairs, bonding pairs, shared pairs, and covalent bonds. How do they look like? Can we just use dots forever? No. Luckily, we have another way to shorten this. So here's what we're going to do. If you have a shared pair, so let's say, or not the bonding, shared or bonding. Okay. If you have 2 dots shared, we don't like to use dots anymore. We're just going to use a line, and that's called a single bond, single covalent bond or single bond. If we have 2 pairs, well, that's now 2 lines, and that's called a double bond. I'll give you an example on this. If we have 3 shared pairs, that would be a triple bond. Now, if you have a lone pair, it remains a lone pair. You do not put any lines because it's still a lone pair. So you leave it as it is. So for example, how do I draw this using this representation? It's H. This is a bond between them. Here it is, a single bond. And then I put the dots on the Cl. So a line in this case means it's a covalent bond. This is shared, so on and so forth. Okay, so let's look at, well, where do you see those double and triple bonds? Where are they? Well, we need to pay attention to this: bond strength and length. So we say single bonds are the longest, but they're weakest bonds, followed by double. Those are the shorter but stronger than the single, and triple bonds are the shortest and strongest bonds. So, for example, Cl2 is nothing but a Cl attached to a Cl. You can draw this. Versus oxygen, it has a double bond. Think about it. O is each with a 6. The only way, okay, they can share one pair, but that would make it 7. So they would have to share the other pair, and that would make it 8. So here's your double bond. And then finally, N2, nitrogen, is a triple bond. Once again, verify that. You'll see that you're going to need to form a triple bond. So therefore, this is the longest but weakest bond. So it's a single bond. This is the shorter but stronger than single bond. And the triple bond is the shortest but strongest. So you would need a lot of energy. Bond. You need a lot of energy to break that bond.